In this video, we're going to take a look at how you solve trig equations that have multiple angles or that have a change in frequency. We would recognize this is happening if when we take a look at the equation, we see that there is a b value, a number between the function and the x. So things we need to remember as we're working on this is that when we were graphing things like sine of bx, b was the speed of our curve or the number of cycles that the graph completed within 2 pi radians. This is really important as we continue on our journey of solving trig equations, because for all these guys we've been solving in the range of 0 less than or equal to our angle less than 2 pi. So we want all the answers between 0 and 2 pi, or all the answers in that first rotation. So if I have a b value, how many times I would make it around, or how many cycles I would get through, is changing. So my number of answers therefore would change. So we'll kind of see how that plays out in just a second. I'm going to start just again by example here. So an example that we could do really straightforward. We've isolated the trig function, and we end up with an equation like cosine 2x equals -1. There could be preceding steps where I got the cosine 2x by itself, but I would have to just add, subtract, multiply, divide to do that. Once I've wound up at this point, you may not divide away this 2. This is not 2 times cosine, this is 2 times the angle. So we can't divide away that 2 inside here until we've figured out the values of the angle. So as a result, we're just going to try to remove that part from our thinking up front. We're going to do something called a substitution. This is very common in higher level math. We kind of take a more challenging component, we kind of remove it so we can think about what else is going on here. So since the variable they gave us was x, I'm going to pick a different variable. I'm going to choose to say theta here because the variable they gave us was x. So I'm going to say let theta equals 2x. In the question, the angle listed was theta. I would say let x equal 2 theta. Okay. Now I'm going to rewrite my equation, replacing that more complicated part with the theta. Once you get a hang of this, there's no reason for you to have to do this, but until we hit that point, we kind of want to give ourselves something that's easier to think about. So really, this is similar to solving the equation cosine theta equals -1. Now here's our difference. Our b value in this equation is 2. So that means that I'm going to complete 2 cycles of my equation. So I want to go through 2 rotations of my unit circle. Okay, so when I'm coming up with my answers, I'm going to get all the answers from the first rotation and all the answers in the second rotation that are coterminal with those. Okay, so that will come up again in just a minute. So as I'm thinking here, I now want to find all of the angles on my unit circle that have a cosine or x value of -1. So if I look at my unit circle, that happens right here at pi. So I can say that theta equals pi. Now that's the value from my first rotation. I also need the values from the second rotation. So the value from the second rotation would be coterminal with that. So one rotation is 2 pi radians. So I can say that my theta equals pi or 3 pi. Now right now it doesn't seem like those are valid answers. At least the second one isn't, because this says it has to be less than 2 pi and 3 pi is not. However, I'm not actually solving for theta. What we were solving for was way up here, x. So as a result, I'm now going to undo my substitution. I'm going to replace the theta with what it initially equaled. So I'm going to say that 2x equals either pi, hold on one second, just want to, my placement's a little bit funky. So I'm going to say that 2x equals pi or 3 pi. And I now want to solve for x. So to solve for x here, This is 2 times x. So in this step of my work, I always kind of make sure I leave myself some space. I'm going to multiply everything by a fraction to get this x alone. So the fraction is going to be the reciprocal of the coefficient to x. So I have a 2 out in front, so to undo 2, multiply by half, but I have to multiply every single angle on the other side by a half as well to maintain my balance. So I end up having that my x, or my angle that I was looking for, could be pi over 2, or 1/2 times 3 pi, which is 3 pi over 2. So my speediness has taken those angles that initially seemed to be outside of the range of my angle, of my answers, and it's pulled them back in. So final answer here is pi over 2, or 3 pi over 2. So initially it seemed like there was not there's only one result, and it actually winds up that there is 2. I'd like us to kind of talk our way through a second example here. So let me minimize this. Let's take a look. I'll put this down here. Let's take a look at a second example. In our second example, I'm going to try for something like a little more complicated. Let's go for a stranger b value. So I'm going to go with the example sine of 4x over 3 equals square root of 3 over 2. So still starting with 1 where the trig function is already identified. If this had been a reciprocal function in this equation, when you're using your rules of proportions, you would not have to flip over the angle portion of it. So if this said like cosecant, and I want to change to sine, this angle notation would stay 4x over 3. It wouldn't come 3 over 4x. Just that's a little sidebar there. Sorry. So if I want to solve this, again, I don't like this 4x over 3. It's confusing to me. So I'm going to make myself a little statement. I'm going to say let theta equal 4x over 3. And I'm going to make myself a note that b equals 4/3. So I want to look for all angles between 0 and 4/3 times 2 pi. So 0 and 8 pi over 3. That's 1 1/4 rotations. Okay, so that's where I'd be looking for my answers. So now I have sine of theta equals square root of 3 over 2. So if I look down at my unit circle here again, I want the y's to be root 3 over 2, so that's at pi over 3 and 2 pi over 3. So I have that theta is pi over 3 and 2 pi over 3 from my first rotation, but this says I need to go 1 1/3 rotations. So I've gone all the way around once, and then I want to go 1/3 of the way around. That's going to take me to that 8 pi over 3. So that is here. So 120 is 1/3 of the way around. So I want all the answers from in this region. So we hit this guy the first time, this guy here, and now the second time around we're going to hit this angle again, but it's going to be coterminal. So I'm going to say that this is pi over 3 plus 2 pi, which I'm going to write as 6 pi over 3 so I can add them. And it actually looks like 2 pi over 3 is where we're stopping, so I'm going to have that angle a second time as well. So my fourth angle here is going to be 2 pi over 3 plus 2 pi, the coterminal angle that goes with it. So we kind of do some simplifying here. I get that theta is pi over 3, 2 pi over 3, 7 pi over 3, and 8 pi over 3. Now again, theta wasn't what we were actually solving for. We were solving for x. So now I'm going to undo my substitution and say that 4/3 x equals, and again, I'm going to leave myself space before all these because I know that I'm going to be multiplying by a fraction in a second. Yeah. Oops, sorry about that. Doing all sorts of wacky stuff to you here. Just trying to give myself a little room. Okay. So pi over 3, 2 pi over 3, 7 pi over 3, and 8 pi over 3. But again, I don't want 4/3 x, I want to know what x is. So to get x alone, multiply by the reciprocal of that coefficient, and I do that to every single one of my answers. Beautiful thing happens here, luckily. I don't know if you see this happening or not, but what I see happens is something kind of nice. For all these guys, these 3's are going to cancel. So I'm actually not going to multiply and then reduce. I'm going to choose to reduce in my first step. These cancel and these two as well. So final answer, x equals pi over 4. 2 pi over 4, which I'm going to go ahead and reduce to pi over 2. 7 pi over 4. And this last one is 2 pi. Our answer range actually told us that we were not including the 2 pi, so I guess technically that means that our final answer is just these. 2 pi is not incorrect, it is a solution, just doesn't fall within the range that we have. Hope that helps.